Today we're going to review area models. The purpose of this video is not homework. It's to help students review area models and make corrections if needed on pages 301 and 302. If at any time the pace is too fast, stop the video and rewind. You'll need a piece of notebook paper, and if you have your corrections out, those as well to look at. If you're doing just review, just get out a piece of notebook paper and pause when you need to. The first thing we're going to do is do a small review on area. So we have a rectangle drawn here, and so here's our rectangle. On the inside of the rectangle, we call that area. So all of this inside of it is called the area. And to find the area, we're going to use length times width. So I've got an L and a W. Length is L, W is width, and area is A. So we do length times width to find the inside of it. But sometimes we are not given the length and the width. We're sometimes we're giving the area and the length, and we have to figure out what the width is. And so we use area divided by length equals width. Or sometimes the width isn't given to us. The length isn't given to us. It's the unknown. And we have to do area divided by width equals length. So we can interchange them. Notice always the area is first when we're using division. It doesn't matter what order we put it in when we're multiplying, but when we're doing division, our area is always first. We also know since the inside of it is the area, we can chop this rectangle up in different pieces. For instance, I can divide this rectangle and I could find the area of this piece and it still would equal the whole amount. Or even chop it right down the side and have three different pieces. So for instance, if this area was equal to 80, this could be, so for instance, if I said this rectangle and this rectangle both have an area of 30, and these two rectangles have an area of 10, if I add them all up, I would get the area of my whole rectangle. So if from here to here and here to here and here to here would all be the same length. They're the same length. And so that would mean from here to here and here to here would be the same lengths. These all would be the same because it's a rectangle. So I could take this length plus this length to get the whole length of the side. And it works the other way on the other side for the width. I can take the width and the width and get the whole width on it. Let's practice one of the problems that we've did. That kind of helps us out to have a better understanding of it. Our very first one was question number 1 on page 301. And so here we have it. We have a rectangle split into some pieces. And we're just going to remind ourselves that area was equal to length times width. We can take area and we can divide it by length and get width. We can take area and divide it by width and get length. But this is kind of like a puzzle. So here's my length, and I've got from here to here is 20, and from here to here is 4. So the total would be 20 plus 4. So we're thinking right now that our length on this one is 24. We need to find what the width is and what the area is on this one. Well, we have two boxes to try to figure out what the width is. So what times 20 equals 60? So 3 times 20 equals 60. That means from here to here is 3. Because 3 times 20 equals 60. That means inside of here is 60. The area inside of that rectangle is 60. Let's put that back. There's my 3. So this was the area inside the thing. This was the width and the length. That's just this one little rectangle. So from here to here is 3. That means from here to here is 3. So this is a 3. 3 times 4 is 12. Well, that's exactly what's over here. 3 times 4 is 12. So we know that the area in this one is 12. We know the area in this one is 60. But we don't know what the whole area is because we still have this piece from here to here. And we've got this box here that says something times 20 equals 18. That seems like a little harder one to do. Let's look at the other one, see if it's easier. From here to here, we don't know. And from here to here, we don't know. But we do know across, so something times 4 equals 3 6/10. So I can come over here and go 4 divided into 3 6/10. It will not go in there. I can bring my decimal up, bring it down. What times 4 equals 36? 9 times 4 equals, oh, that didn't do. Let's try that again. So 9/10 is what goes here. So if we think from here to here is 9/10, here to here is 9/10, should be from here to here is 9/10. So this should be 9/10 times 20 equals 18. We need to check that. 20 times 9/10. 9 times 0 is 0. 9 times 2 is 18. One number behind the decimal, sure enough, it works out. So now we have 3 plus 9/10. 3 plus 9/10. We have to line up those decimals when we add. Put me some placeholder zeros to hold on to it. So we think that that is equal to, the width is equal to 3 9/10. So now I go back and look and said, okay, well, we said 9/10 times 20, length times width equals 18. In this little box, 9/10 times 4 is equal to 3 6/10. So we have the area for all of them. We also know here, they gave us this. They said something times 24 equals 93 6/10. Well, we know this something is length. So this must be our width, and this must be our area. We have a couple of ways to check it. I could do length times width, which we found right here. Here's the length. Here's the width. I could do 24 times 3 9/10. I could take all of the areas and add them up. Either one would get us our answer. You choose which way that you would like to do it. And do it now. And pause the video. No matter which way I did it, I got 93 6/10, which is exactly what we have. So the problem asks us to fill in our division problem. Area divided by length equals width. And what did we decide the width on this was? 3 9/10. 3 9/10. We filled in all the pieces to this. We have all the pieces to the puzzles. There could have, like I said, there's lots of different ways. Let's look at the other two problems. Here's our next one. So I'm going to first start working on the outside. For my length, I've got 10 plus 9, which is equal to 19. My length is 19. I'm going to look inside my boxes. What times 10 equals 90? 9 times 10. Let's try it over here. Fill it in. 9 times 9 is 81. Sure enough, that means from here to here is 9. Then I'm going to look here. And I'm going to say, okay, something times 9 equals 2 and 7/10. So I'm going to come over here and do some division. What times 9 equals 27? 3. So I think this is 3/10. So this would have to be 3/10, which makes this 3/10. So I need to check it to see. 10 times 3/10. Sure enough, it equals. And so my width there would be 9 and 3/10. So my width is 9 and 3/10. I have areas here to be able to add up. 90 and 81 and 3/10 and 2 and 7/10. Got to line up those decimals. I lined up my decimals and put placeholder zeros. Bring my decimal down. 3 plus 7 is 10. Carry my 1. 1 plus 1 plus 2 is 4. 9 plus 8 is 17. So it looks like that my area is 174. So then I'm ready to fill it in. We know that it has to be area at the beginning each time. We know that this is my length, which this equals my width. So I'm going to fill in what I know. 174 is my area, 19 is my length, and 9 and 3/10 would be my width. Let's do another one. Once again, it's like a puzzle. So I want you to look at it, and I want you to use this one to see if you can do it on your own. And then turn the video back on and see how you did. Okay, we're back. So they've given us the length. 10 plus 6 is 16. So our length is 16. So now we've got to figure out what our width is. We've got blank times 10 is 8. Can't think of anything off the top of my head. And I've got blank times 6 equals 4 and 8/10. I can do some mental math and say I know that I can ignore my decimals and say 8 times 6 is 48. Got one number behind the decimal. I would need one number behind the decimal in my problem. So if from here to here is 8/10, that means from here to here is 8/10. So this is 8/10, and here would be 8/10. And I would go 8 times 10, ignoring my decimal, put one number behind the decimal, and sure enough, I would be good. Now I'm ready to skip this one. What times 10 is 8/10? What times 6 is 48/100? So I can ignore my decimals and say 8 times 6 is 48. And I need two numbers behind the decimal. So two numbers behind the decimal. 8 hundredths, 8 hundredths. And so I can say 8 times 10, which is 80, and hold on. I can come over here and check it, and sure enough, it comes out the same. So now I've got my width, 8 and 8 hundredths, So I've got my width, I've got my